active as well. About a minute into flight, we'll hear calls for flight through max Q or maximum aerodynamic pressure, and then we'll about 2.5. Strong record track has been completed. There you go. You can see a nice separation there between the rocket and that transporter erector. About 2.5 minutes into flight, we're expecting to see a few things happen very rapidly. We're going to see that booster separate after that first stage engine cutoff happens, and then after that separation takes place, the second stage.
Stage 2 LOX load is complete.
There's that stage 2 liquid oxygen load complete, which is great. You kind of see some of the steam coming off the vehicle. That's dealing with cryogenic fluid that's on the order of negative 330 degrees Fahrenheit. It's densified liquid oxygen mixing with the ambient temperature there, which creates that fog, that steam effect. So we'll also see a lot more happening post liftoff, so stay with us. And we even have a lot very, very late into the show today. We're roughly an hour and a half of milestones past liftoff of getting into the correct orbit and confirming that we have a good, healthy spacecraft. So please stay with us. There's a ton going on, but we'll let you listen in these last minute and just enjoy the countdown.
Falcon 9 is in startup.
Launch director is go for launch and landing.
You may notice some water beginning to flood the pad here. That's very intentional. That's actually a sound suppression system that occurs to allow the sound of the vibration of the sound to actually be suppressed, and it also helps with some cooling as well.
Falcon 9 is configured for flight.
T-minus 15. 10.
9. 8. 7. 6. 5. 4. 3, 2, 1, 0. And liftoff of Sentinel-6, Michael Freilich, continuing a legacy of ocean observation and international collaboration to benefit all humanity.
M1D propulsion is nominal.
Power and telemetry nominal. Vehicle is supersonic. Vehicle is experiencing maximum aerodynamic pressure.
So there we heard that call for max Q. We also heard vehicle is supersonic, meaning it's traveling faster than the speed of sound. A beautiful shot there from the first stage looking down towards Earth and seeing the plume there created by those 9 Merlin 1D engines. Beautiful clear skies there from Vandenberg on the ground. Able to track with that rocket as you see it on screen now. Just a reminder coming up here very quickly, we're going to hear booster or first stage engine cutoff.
Stage separation confirmed.
Booster separation is there visible on screen now. Beautiful shot. There's the backflip, as Jesse mentioned, beginning with the Falcon booster.
Stage 1 boost burn is started.
And that second engine looks like it has lit. You can start to see the engine bell there turning an
Both
orange.
vehicles are following nominal trajectories. Fairing separation confirmed.
And there goes the fairing. That's exposed. That is Sentinel-6, Michael Freilich there on your screen. That is the satellite that has been exposed now because the fairings have been jettisoned and separated, and you just saw it there tumbling away. Some beautiful shots on the way to orbit.
And stage 1, boost pack burn shutdown.
So we're getting reverse angle views of that engine on screen. That's what you're seeing. This is switching between opposite sides of that second
Both
stage.
vehicles continue to follow nominal trajectories.
And that term nominal being used, we've heard that a lot during this call out. That's a very good sign. Nominal just means that everything is going according to plan within the expectation of operation for the vehicle. So we are, there, a great shot from the first stage. You can see the hypersonic grid fins there that are expanded, those honeycomb-shaped structures. As the booster begins to enter the atmosphere, those will be able to help guide and stabilize the booster to make sure that we hit that pinpoint landing like we heard that question asked. How do we ensure pinpoint landing? And those grid fins play a huge part in that. That second stage is in the middle of its first burn. This burn will last approximately 6.5 minutes. And then there will be a long coast phase today. And then we will have a very short, a relatively short second stage, second burn to put us in the correct orbit to follow that path of the Jason series, as we heard earlier. So, Philip, from a trajectory perspective, is this just kind of a moment where do the people working this mission, do they kind of just sit and wait as well here? Because obviously we're not controlling this actively. It's just the vehicle, in theory, just doing what it's programmed to do.
Right. I mean, I will say I didn't personally work this mission, so I'm not sure what my coworker who worked it for the past couple of years is thinking, but it's beautiful to watch this trajectory that we've been planning out for years. We know what the math looks like, we know what the numbers are, but actually seeing these views from the second stage is just amazing.
Yeah, very good. And we'll talk more about kind of your role, what you do as a trajectory analyst. You are, by all accounts, a rocket scientist, which is pretty cool. We will come back and chat more in a bit. Well, again, we'll revisit you once we get towards that second stage, second burn. But for now, I think we're ready to head back out to check in with Daryl and Jesse to hopefully enjoy
nominal trajectories.
What I would expect to be a beautiful, very noisy nominal landing of that booster. Daryl, how was launch? How did it look out there? All right, we're going to hang off. They're not quite ready yet. I'm sure they're just enjoying it. They probably got up to watch that launch, and they're probably getting positioned again. So I don't blame them.
Me neither. Yeah, they should definitely soak it in.
So that second stage Merlin vacuum engine, MVAC as we like to call it, that produces around 210,000 pounds of thrust once it's on orbit in the vacuum of space.
Stage 1, entry burn has started.
All right, so call for the entry burn there. I think Daryl and Marina are ready for us. They should be there with Jesse to talk us through the landing. How was launch?
Os motores são ligados.
Oh my goodness.
Incredible.
It was incredible.
We're all talking at the same time. It's great. Can you tell that we were
It's
excited?
amazing.
We're standing there. We saw it. It was so clear we could see the separation as it was going the entire time. Jesse, I mean, isn't that
Awe-inspiring.
Mind is blown.
so? It's going to be landing right behind us, and we've got a view now of the actual booster coming back. It's got its grid fins out, and that's helpful. It has to use those things.
It has to help steer it as it's making its way back to land. So it's a steering mechanism.
It's really interesting that it lands right next to the launch pad. We have a little tent over top of us, so we're not going to see that first boost back. But we have a clear shot of it coming down onto the pad. The other thing we're waiting for, and we're making sure that we keep track of, is
Os
the
motores
engine
são
cutoff in
ligados,
stage
as três
2.
fins eles
And we're going to
se
call that out.
movimentam para
Here it
conseguir
comes.
manter
There it is.
Wow.
o primeiro estágio
Coming in at an
equilibrado.
angle and just straightening out. What do you think, Jesse? That's amazing.
Oh my goodness. I might cry right now.
This is so incredible. Every time I see this, it's just
Slowing down so perfectly.
perfect.
Just hovering. There's the sonic booms we talked about, and touchdown.
Oh my
We heard that.
Pousou,
Yes.
And Falcon 9 has landed at
pouso
LZ4.
perfeito,
Beautiful.
To 11.100 on recovery 2.
exatamente na marca
The power to see it
onde
here in
deveria
person,
pousar.
feel it.
Oh, and like Jesse said, no matter if you see it or not, you always hear it, right? That sonic boom is recognizable
And
wherever you are.
reverberating through the valley
Oh, I
here.
know.
I love that.
Well, what'd you think, Jesse?
I have no words. That was incredible. Like as many launches as I've seen, seeing it in person is a whole different experience.
The crowd that's with us, you can hear them cheering and everything. They're just totally like, you know, in awe.
Oh,
We're
it's
so
amazing.
glad that we could do this and have you join us with this. Jesse Anderson from SpaceX, lead manufacturing engineer. Thanks so much for coming out here. What a moment.
Thank you so much for having me. This has been amazing. Thank you.
All right. Well, the coast phase is about 45 minutes away. And so you don't expect any activity to report at this time. But if there is, we will let you know. And in the meantime, we'd like to tell you about the science behind the Sentinel-6 Michael Freilich mission. And we're going to get to that in a moment. But, you know, we have a moment here where we're going to sync up and simulcast with our partners from the European Space Agency. And when we do that, that's going to allow both channels, both ESA and NASA, to carry the same broadcast at the same time. Going to talk a lot about science, and we're going to get to that in a moment. But first of all, I want to get your reaction to watching both the launch and the landing.
And it's spectacular, Daryl. I mean, it's so beautiful when everything comes, and like Jesse was saying, a well choreographed ballet. It's the best choreographed ballet in the world, and it did everything that it was supposed to. The launch was beautiful. I'm so glad the winds quieted down when they were supposed to, so that we could get that rocket launched, because this is incredible science that we're going to get from Sentinel-6, and I just can't wait.
Well said indeed. Okay, now we are going to turn it over to our friends from ESA. Let's join moderator Louise Houghton from the European Space Agency.
Really would like to thank NASA and our friends in the US, also NOAA, for this contribution they've made. Incredible. They've been an excellent partner. They have been very reliable, and they really have delivered their part on time and very significant terms. The launcher we have just seen, but also very important instruments like the microradiometer and several other components. And this is a multi-cooperation. I would really like with Thomas and his team in the US discuss further cooperation opportunities, because this is just so wonderful what we have done with Sentinel-6 Michael Freilich, and there's much more to come. I have quite a few ideas. I don't want to go into depth right here, but I think this is so successful that I would like to expand that.
Well, thank you so much, Joseph. I think you're saying there that international partnerships are so important for these space missions moving forward. And we've, of course, been able to monitor the oceans from space for nearly 30 years now. And before we continue this conversation, I want to take a look at a video which will show our achievements to date.
Right.
Sorry, this is...
You're coming back to me, or?
Yeah, we are. What would you like to ask me, so I can gather my thoughts?
Okay.
What difference is Sentinel-6 making to revolutionizing oceanography?
After the video, you'll have like 6 minutes.
I don't hear the video.
She's missing.
She doesn't have a feed. Give me a feed. altimeter was actually an experiment on board Skylab, which was 50 years ago now. I mean, the way that this technology has transformed over this last half a century is quite fantastic, isn't it, Thomas?
Oh, it's amazing. I mean, for me, when you just think about it, you know, you have this spacecraft up there at, you know, 1,300 kilometers, going at 8 kilometers per second, and you're locating it within a centimeter or so, exactly with all these, with the altimeter, but also the GPS receivers and the supporting instrumentation. For me, it's mind-boggling, you know, and of course, it's so important because it affects our lives in a direct fashion every day, even if we don't not notice that.
What challenges do you think that we're going to come across in the future with working with this international partnership?
So look, I believe that for the first couple decades, the question really was, are the ocean levels rising? The question to that is absolutely yes. Now, the question that we're dealing with, and as an international community, is how are we handling these rising oceans, and how do we make sure we don't go to levels that we don't need to? And so for us, kind of the local impacts of those around the world, whether it's in Europe, whether it's in the United States, and everywhere else, are what's going to drive our research, and therefore the high resolution that this spacecraft provides us is absolutely critical. So that's the question. The international community has to come together to deal with these problems, because each one of those assets, you know, serves all of us.
Well, we have been hearing more and more about how oceanography has been revolutionized by satellite observation. So Nadia, maybe you can tell us a little bit more about why Sentinel-6 is making such a difference in that development.
Yes, Sentinel-6 is indeed building on a very rich heritage of JSON-class altimeters, and what we expect to see a new science coming out of Sentinel-6 that it would open up new frequencies and give us a fuller picture of what do we know about the oceans. And ocean altimetry by now, it's a mainstream tool of modern physical oceanography. So if you are a modern oceanographer, at one point of your life, you clearly looked with this data. Either you're studying tides or sea level, ocean circulation, or winds or hurricane prediction. You were exposed to this data, and we expect from Sentinel-6 to continue doing this discovery on a higher resolution and longer time scales.
Well, if Craig can hear us over in Europe, maybe I can come to you as well, Craig, and ask you your opinion on how this technology is really changing how we monitor the oceans.
To our precision, which is essential because the genuine changes in just a few millimeters a year. It's really remarkable. But you know, you can do a lot more. And recent work shows the oceans are taking up much more carbon dioxide from the atmosphere through the ocean-atmosphere interface, where waves play an extremely important role. Now, the Sentinel-6 Meteor Microfluidic Radar altimeter provides us with excellent measurements of the significant wave height with a 300-meter footprint size along the satellite track. Really, this will help us to improve our understanding of carbon dioxide transfer into the ocean. But it's even more than that. Wave forecasting is part of the Copernicus Marine Services for serving maritime operations, which are essential for maritime safety, and these are managed through the European Maritime Safety Agency. So we'll have topography measurements and wave measurements to really provide something pretty superb.
Well, thank you, Chris.
If you wish, it is up to you.
And that was Craig Donlan, who's the project scientist from ESA, which is the European Space Agency. So thank you so much to them. And the climate science conversation continues. If you would like to tune in, just use the Sentinel-6 hashtag on the European Space Agency or ESA's social media platforms.
The satellite was renamed after American oceanographer Michael Freilich, who led NASA's Earth Science Division for more than a decade. Freilich passed away in August, but 5 months prior, NASA held a satellite renaming ceremony for him at the agency's headquarters in Washington, D.C. Freilich accepted the honor, but he credited his success to the